Hello and welcome to zebracode.io. This is a free coding curriculum for high school students, and we are on Lesson 8. And in Lesson 8, we're going to be talking about user-defined functions, and this is a demo. You should be comfortable developing in our browser-based system, or in this case, I'll be developing on the PC here directly. So I have idle, I've opened up a blank file, and I have two screens open, one to the command prompt and one to the text editor here. So the first function is going to be def, and that defines a function, and we've created one called addNums. In this case, it accepts two parameters, a and b. So now I can say x is assigned the value of a and b and return x. Now I can simply say return a plus b, but in this case I want to be very explicit and write out every line of code. Now so here we have the function. All of the functions always go on top. So we can have multiple functions here. In this example, we only have one. Now I'm in my main program. Notice I'm indented all the way to the left. I create a new variable called mySum. It's assigned the value of addNums, which is the function name. In parentheses, the two parameters I'm passing are 4 and 5, and then I print the value. So let's go ahead and save this. I'm going to be save this in my homework folder into lesson 8. And now I'm going to call this fx.py, and you can call it whatever you feel is appropriate. Remember the .py file. So now to execute this code, we simply navigate to that same folder where we just saved it, and I type python fx.py, and notice I get the results back. It prints out 9, which is the two values, 4 plus 5, and those are the parameters. Let's do some minor editing here. Instead of integers, let's change these to float values. It's going to be nothing different. We can use the up arrow, run the code again, and we get essentially 9.4. So very simply, we can define our function. We use def. Then we have the function name that must be unique. It's similarly to naming a variable, and it must be case sensitive. And then we pass our parameters to it. So let's take this and change it slightly. Let's create a new function. It's going to be def. It's going to be the same name. Instead of taking two parameters, a and b, let's take a list of parameters, or a list. L will represent a list. I'm expecting a parameter of a list. So s equals is assigned the value of 0. Now I'm going to iterate through the list for x and L. S is going to be assigned the value of s plus x. Each time we iterate through the entire list, each item is x. We get the entire sum here, and we return s. So this is just basically taking this list of numbers here that we're getting, we're going to add them all up, and the function is going to return the value. So now I can define L in my main function. It doesn't have to be L. In this case, I can use a different letter than the capital L, but in this case it's the same, it's fine. I'll illustrate the global and local variables in a moment. I'm creating a new variable called mySum. MySum is assigned the value of addNums, and it's going to take the parameter. In this case, it's going to be a list, and the list is going to be equal to the items 2, 3, and 4. And now we can print mySum. So let's go ahead and save this. You can use Control-S to save it. And now let's run this code again. And it's going to run through, add all the items. 2 plus 3 plus 4 is 9. And so let's change this to one of these items to a float, and once you have one as a float, the whole return value becomes a float, and we get the appropriate value of 9.1. So this is the exact same thing we did before, but instead of passing two parameters a and b, we're passing a list represented by a variable called capital L. Now notice I'm going to print s here, and the idea of local and global variables, s only exists within the confines of the function, and here we're in the main program, we're trying to print s, and we get an error, name s is not defined. That's because everything that exists in the function, all the variables are local only, and they don't exist in the main program. Another way to think about this is a function only has an input and an output. The inputs are the parameters, and the output is the return value. So that's limited, and think of it as a black box. Let's give another example. Def is defining a function. I'm defining it. I'm going to call it calcAverage, or calcAVG, and it's going to take an input value of a list as well. And we can do similarly as before. S is assigned the value of 0. For x in the list, it's going to iterate through all of the items. S is going to be assigned the value of s plus x. Initially, s is 0, and then as we iterate through the list, it represents each value of the item in the list, and then finally we can return s. Now, if I want to get the average, s is going to equal the sum, and I can divide it by the length of L, or the number of items in the list. So now this is going to return a value. It's going to be a float value because we have division here, and to call the function, we do exactly as before. I'm in my main program now. X is assigned the value of calcAverage. In this case, it's going to take a parameter as a list, and I'll put that list directly into here, 2, 3, and 4 again, and we can print L. So this is going to calculate the average of all of the items in the list, and when we run through this, we can run it and get the results. So let's first clear. CLS is clear in the Windows environment. It's slightly different in the Linux environment. And we get 3.0. That's the average. 2 plus 3 plus 4. If you add them all together, that gives us an average of 3. Let's add another number here, 5. And let's run this again just to test our program. And now we get the average as 3.5 based on those 4 numbers. Now, I want to illustrate one additional idea is that when you return a value, so far we've only returned one item. In this case, we can return more than one item, and this will give us also an introduction into tuples, which we'll learn about later. So tuples are simply go in a parentheses, and we have 2 items here. So this is going to actually return 2 values. And to make it a little bit cleaner, I'm going to create a new variable called AVG that represents average. Remember, this is a local variable, and average is going to equal S divided by the length of L, just as we had before. And then when we return, our return value is going to be a tuple, or it's basically, just think of it, I'm returning 2 values, and I put those in parentheses. One is going to be, the first position is going to be the average, and the second position is going to be the number of items in the list, or the number of items that we, in order to calculate the average. So, and here we get, when we run that exact same code, we return a value, and the value has 2 parts to it. It's got the average first and the number of items. So very simply, it allows us to, the idea that we can return more than one value. Now, if you want to explicitly get the first value, which is the average, or the second value, which is the length, we can note this by the square brackets, 0. It's based on 0. 0 is the first position, 1 is the second position, etc. And now we get to print out those 2 lines, and we get first 3.5 is the average, and the length is 4 based on the position. The 0 position, or the first item in the list, is 3.5, the average, and the next one is the length, which is 4. So the idea here, I just want to illustrate, is that most of the time, or often, you're just going to return one item. But if you need to return more than one item, you can easily do that simply here with those parentheses, which is a tuple. Let's do one other example. In this case, we're going to have no parameters, and we're going to call it, we're going to define our function as build deck, and it has no parameters. And here we're going to do a nested loop, and for CN, this is going to be represent the card. So let's go ahead and list out the 13 items, possible cards. A is an ace, K is a king, Q is a queen, all the way down to the last one, which is 2. So this should be 13 cards here. And now we're going to do a nested loop. So notice the indentation for S in, and here there's going to be 4 options. It's going to represent the suits, diamonds, clubs, spades, and H for hearts. So this allows us now, if we do a nested loop, we're going to have 13, and we're going to have 4. We multiply those. That's actually going to give us 52 items. And we're going to have to return a value. Let's call that deck. And initially, deck is going to be an empty list. And in this case, we're going to iterate through here. We're going to go 52 times. We're going to now have 2 strings, C and S, and we're going to concatenate them together. So AD is going to be represent ace of diamonds. K, H, for example, would represent a king of hearts, and we can return the deck. So this is going to return a deck. A deck is a list of 52 items, and they're going to be a string with 2 letters each, or with the 10, it's going to be 3 letters, or 3 characters. And so now D is assigned the value of build deck. Notice no parentheses, and we're going to print D. And let's go ahead and clear this, run this again. And here's our 52 items, and it's all the cards. There's all of the cards here, starting with ace of diamonds. And we'll take another look at this in a minute. But let's also not only print the deck, but let's print the length. And let's run this code again. And now we'll get the 52 items in the list. And notice the 52 here, that represents the count. So we do have all 52 counts, or 52 items. Let's take a look at this code, just very little bit, snippet of code, a couple nested loops, a function here that we could use over and over again, and then 3 lines of code, which represents our main program. And so the idea is with functions, we can build little snippets of code that are reusable. And with parameters, we make it very flexible. We can pass different parameters to do different calculations. We can return one item or return multiple items, and we can have many functions all within a program and call those different functions. So that's a brief demo of functions. This is zebracode.io.